Hello, welcome back to my shop. We're going to get a little handheld action here. I've done a little bit of work on this Jackson Bell, and looks like we're not going to fire this thing up anytime soon. The transformer's got some bad wires on it, and it actually has to come out for a couple of reasons. I'll show you that in a second. It's got some rust on the chassis here. That's not a big deal, but we can deal with that. Now, I don't know how well it'll pick up on the camera, but let me back out a little bit. Sorry. But if you can see, the transformer leans back just a little bit. And I don't know why, but whoever worked on this before put some kind of a washer in up there, and that keeps it lopsided, and I don't know why that was like that. But the problem is this can that covers the coil doesn't go on flat unless it's hitting that transformer. So that transformer is going to have to come out. The other problem is, let me swing this around a little bit. If you'll notice, I've got the on-off switch out. And the reason for that is, there it is. It's a very odd switch, but these lugs here are very loose, and this switch is kind of strange because it's a continuous switch. It doesn't click on, doesn't click off. What it does, you turn it, that cam pushes down on this lever right here, which makes contact. That turns it on. If you continue to turn it, it goes to a flat like it is now, and it goes off. So there's no positive on-off. There's no way I can find a switch similar to that. So we're going to try to see if we can clean that up and fix it. Other than that, I've taken quite a few pictures of the chassis, the upper side and the lower side, because we're going to have to start taking some stuff off of here. So let me flip this over and we'll see what's got to be done on the bottom. If you can see that or not, that's a wire wound capacitor, and it's just like that one. Well, it's supposed to be just like that one. That one looks like it got caught in a rainstorm and its hair frizzed. I mean, it's completely unwound. So that's going to definitely have to be replaced. We're going to take out, there's a box here and there's a box on the other side, which I would think would be a capacitor in each one, but I don't know for sure. You'll notice that I took the two box-shaped electrolytic capacitors off of there. So what we're going to do today is we're going to do a little dissection of one of those cardboard box capacitors, and we're going to reproduce it. I don't normally do that because nobody pulls apart a radio to see if there's actual replacement capacitors or that underneath it. And in 50 years, when this thing needs to be done again, I'm not going to be around, so it's not going to matter to me. So let me take you over there, and we'll see what we got going. Okay, this is one of the two box capacitors. I've never seen one like that actually, which is one reason I'm going to restuff it. You'll see it's what they do is they make these things and then they dip them in wax, and that's the wax, it's the dirt it's accumulated over the years and years. But right now what we're going to try to do, I know you can't see it on the video because I can't see it by looking at it, but there is writing under there. I know it's a Sprague, and I know that it's an 8 microfarad at 450 volts, but that's about all I know. So let's see if we can discover some stuff. Okay, got you on the tripod so it won't be so jerky. There was two of these. This is actually the inside of one. This has got foil and dielectric, very thin sheets like paper, and they're rolled together. Maybe later on we'll take these apart and I'll show you what they look like. But in the meantime, we have this. We have printing hiding underneath this wax. So what I'm going to do is we're going to start melting the wax. Now I want you to remember, if you've never done this before, it's very dangerous and you could start a fire, so make sure you do it maybe outside. But I've got a pencil and paper at the ready, which isn't cooperating. There we go. Okay. I'm going to cut the flame down a little bit. Now I've got a towel here that might help to loosen up some of the wax. So we're going to take just real lightly. Yep, that's a little better. You can't be too aggressive because this will rub the ink off too. Which it's doing. So I've tried using solvent on these things, and it definitely dissolves the ink. So let's see what we have here. Well, it's getting better. It says Sprague wax. It says Sprague wax something. Well, I'm not quite sure what that says. Probably says condenser. You know, I can't hold this, rub it, and use the torch at the same time, so we're going to put it in the vise with the rubber jaws. We'll readjust you here in a sec. There we go. It's a little better. Okay, now let's see if we can it's actually turning the wax clear, but I don't want to leave it like that too long. And it's got a patent number too. These capacitors weren't made to last 80 years. Actually, back then they were called condensers. You've probably heard the term. Capacitor, condenser, tomato, tomato, it's all the same thing. Alright, let's see what we have here. Magnifying light time. Yes, that's exactly what it says. Sprague dry electrolytic condenser. Capacity 8 microfarad. Voltage rating 450 volts DC. US patent number looks like 1,710,073, 1.714. So I suppose I could look that up and maybe I could find out what the deal is on it. But that's good. We got that. I do think that I misspoke a little bit. We're not going to restuff these. What you do when you restuff a capacitor is, and these are usually for the metal can capacitors, what you do is you gut the capacitor, gut the cylinder, and you take everything that's out of it, all the gunk, and then you put new capacitors in it, and then you seal it up so that you've got an exactly period correct capacitor. What I'm going to do here is I'm actually going to reproduce the box. The box, the printing, I'm going to put a new capacitor inside and it's going to go in just like an original. Does that need to be done? No. Can you get by with doing it with just replacing the capacitors? Yes. And I'm not going to do it with any of the other capacitors in it. Just this one I've never seen before, so it's kind of a challenge. So now on the side here it has a number. It's 2803. I have no idea what that number is. Possibly it's a part number. And there's nothing on the other side but dirt. Nothing here. Now you see these two terminals coming off this top end here. We're going to have to put some terminals in the new one like that, which will not be a problem. Let me get this old one. Now you'll see this was a connection to one side, one end of the foil. And this is a connection to the other end of the foil. So this would be the center, this would be the outside. So basically what it is, and don't pick on me, but most of my stuff is a food analogy here. Okay, let me see if I can get this in. Yeah, let me see if we can get you a little bit better view. get something a little bit darker to write with. Okay. A capacitor is basically, looks like this. Looks like a jelly roll, actually. And when I said, oops, sorry about that. I hope you can see that. Oh, there you go. And when I said the inner foil, that means this end here in the middle. And when I said the outer foil, that means this one out here. Now, this part that's black would be the cake. The part that's the cream inside would be what's called a dielectric, which is some sort of a film. Usually it's a type of paper. And in between them is what's called an electrolyte. And the electrolyte is what maintains the balance between the rolls, so that the jelly filling doesn't seep out into the cake. I don't know, that's the best way I can explain it. Now, what happens when they get old? Well, when they get old, the dielectric breaks down. And sometimes when it breaks down, it creates a short. And when that short occurs, the capacitor is no good. I'm sorry, I'm not left-handed, so I'm having a hard time getting this in the camera. Okay, it's shorted out, and the capacitor will not, number one, it won't have the proper capacity, and number two, when it shorts out, it could short out whatever it's connected to. Say, for example, one of the tubes or something like that. That's why you should never take an old radio and plug it directly in without examining everything. For example, if this radio was plugged in, it might work, it might not. If it did work, I guarantee you it didn't work good. I'm sorry, it didn't work well. But it could be disastrous. If this broke right close to here, so it would ground this out between here and here, it could have very, between here and here, it could have very well damaged the tube. So that's why these things need to be checked out. I was hoping that maybe I could get this thing plugged in and we could see if we could get it going, but there's too much wrong with it. First of all, that resistor that is looks like Albert Einstein's hair is not good. It might still be working, but it's only a stone's throw away from shorting out and ruining something. The other capacitors I haven't checked. The resistors I haven't checked. Those all have to be checked to see if they're within specifications. But I think what I'm going to do before the next time we come is I'm going to see about making a new box for that. I'm going to order some capacitors, which I haven't done yet. And I'm going to actually have to order a couple of tubes. And I would like to state this right now. You are lucky. I had another video that I was going to post before this one of testing the tubes, but quite frankly it was so boring I fell asleep while I was editing it, so I saved you from that. But anyhow, I did test the tubes. A couple of them were, one of them was bad, one of them was borderline, so I'm going to have to order a couple tubes too. And I did have also on that one where I checked out the speaker. And the speaker isn't great, but it's repairable. But I have to check out the coils to see if that's a repairable unit. If the field coil is bad, we'll have to find another way to replace that. We might be able to put in a modern permanent magnet speaker, but That's counting our chickens before they're hatched. Okay, the other thing I want to show you here, this is a coil, RF, IF, I'm not sure. But anyhow, this wire here, let me see if I can get you in a little closer. Ah, there we go. Now let's see here. Okay, we'll autofocus, I hope. Well, then we'll bring you out a little bit. Okay, now if you can see here how the insulation is cracked and broken and it's off of this lead here. The same is true with this one. And this one, a couple other ones. And also, on the transformer, you probably can't see it, but we'll see. This is no problem. But here, the insulation is worn back, and this bare wire is very, very close to this contact below here. Whoever changed the cord, this is part of the line cord that came in. And I'm assuming that might be why this was shimmed up down here, but I'm not sure. So, okay. Anyhow, like I was saying, I'm not sure that was why it was shimmed up down here or not. But we're going to have to, I think, take this off. The actual wiring harness underneath which is under here, and there's a wiring harness up in the top there, down in here. Looks actually pretty good, so we might be able to get by with splicing some of those wires. But that resistor there, can't see that, can you? This resistor here, and I think this one I'm going to replace too. Those definitely have to be replaced. And then I have to check the values of all of these. So we're going to, unfortunately, we're going to be here a while. I went through my stash of grommets, and I found this one, but it's a little loose, but we'll see. This is the kind I really wanted to go with, the plastic kind, because when I put the period correct cable in there, it's going to be cloth covered, and the new kind that squeeze in there on the vinyl ones does not match. So we're going to do that. So for now, and then we'll show you how to get some of this rust off of here and off the cover that went on here. But what I have to do is I've already made a drawing. I don't know if you can see that or not. But anyhow, I made a drawing, and I marked all of these terminals. This is the transformer, and this is this up here. When I start taking it apart, I'm going to assign numbers to here, and I'm going to put a piece of label maker on here and put the number on there so I know exactly where it went. I still haven't brought the schematic out, but the schematic is not going to be a whole lot of help. It's actually going to be easier doing it this way. So, with that, I think that's all I have for today. So, thanks for sticking with me. I appreciate it. Any comments, constructive criticism, suggestions are greatly appreciated. Sorry about that. Are greatly appreciated. And your subscription is definitely appreciated. So, let me know if there's anything you specifically want to see about this, and we'll see if we can get it in. And if anybody is masochistic and wants to see that tube video, we'll see about getting it in here. I don't even think I have the whole thing anymore. But I'm not responsible for what happens after you watch it. You may go to an insane asylum. Hey, remember, I'm new at this. Okay, that's it for today. Thank you for watching. See you the next time.